anybody else, or did you want to jump in?
Jump away.
All right, so really the goal for today was page turn. We will not be going through every page because that will take us a couple of days if we did that. So we'll focus on kind of the primary pages for each of these projects. If there's anything specific you want to see, let me know that, and we can definitely cover that. There are the two buildings, obviously. There are all these different divisions. So this one specifically, this is the CTE building. General provisions, that's cover sheets and that sort of thing typically. Code review sheets, this is where we get into the specifics of the code, which we can cover, but I would tend to skip there. Civil is our site-related elements, so we can go over a couple of sheets there, site plans. There's demolition, structural, all the various aspects of the project. So if there's something specific you want to see, we can definitely dive into that. My goal was to circle back with John and Jim Rivard over at Thorson Baker on the technology side of things, and then Rich, if there's anything specific you wanted to jump into with mechanical, plumbing, electrical, we can obviously do that too, but I'd like to pull in the engineers, and we can do that with a virtual meeting or something. It would probably be more effective than this meeting. So that being said, I'll cover primarily the architecturals and some of the site aspects of the building. So just for starters, again, this is the CTE project. Really what we're looking here, everything is very similar to what we've seen previously. There's the primary corridor here, cafeteria, common space, welding, and then woodshop space. So really the project still has there's obviously the entrance off the hallway. We're doing some work here at the hallway in order to cut in these new doors. We do have to shift this wall. Obviously, in order to cut in that corridor, we have to shift this wall, put in a new wall that separates, the bistro space from that corridor, creates some woodshop storage space. And then we did end up having to cut in a technology closet for the components that go into that space. Moving further into the building, there is this cross corridor space here. It gets you over into the cafeteria from the main corridor. Off of that, there are some doors to the exterior, the door into the commons, the two small restrooms, single-user restrooms, and a drinking fountain down in this location with bottle filler. Moving back into the main corridor, there's a closet here which has water heater and roof access at this location. At this end of the page, you do have advanced manufacturing, shared classroom and construction, trades classroom. There's a stairwell that gets you up into welding from that primary corridor, and then this is not a vestibule per se, but this is kind of your entry into this side of the building. So there's doors at this location. Looking into these rooms, we did end up adding that sink we had talked about. There did need to be a utility closet carved out of this corner to house all of the fire suppression for this addition. So there's a little closet piece that got cut in there. I'll have some electrical panels, and then obviously the plumbing for the fire suppression. Outside we do have a handful of bollards, just steel pipe bollards to help protect this corner of the building. You're gonna have your gas meter that's relocated from this corner over to this corner of the building, and you're going to want to protect that at that entry space. And then last on this sheet, there is this access way that gets you into the crawl space. So this was something that got added at one point because previously that had just been existing to remain. But since we're reworking all of this, we got that new piece cut in there. Any questions on the plan?
Closet for John's IT switches.
Mm-hmm.
Where's that going?
That's right here.
Okay.
Yeah, and that's right off that woodshop storage. We had looked at potentially using this. This space is just too small.
Okay.
So that's where we ended up with that.
What are the dimensions on that?
It looks like it's about 5 feet by 7.
Oh, perfect.
Yeah. So it should be a nice sized room. It's got a full size door to access it. And it's right off that corridor, so you don't have to go through a room to get to it. So
Is there gonna be any AC running into that room?
he does have ductwork running to that room. Yes.
Okay.
Yep.
So the door to get into the wood shop storage is around the corner down the hallway?
Yeah, you go down this hallway and it's into there. Yep.
How do I feel about that? I feel like it creates a spot where kids can hide. If they're going down there. Does anyone else who's an educator feel the same way? Is it possible to put the door in the hallway?
If we did that, then we would have to carve the tech closet into the wood shop storage, which we can do. We could
No,
just,
that's
we could
fine.
run this wall across and put a door here, if that'd be better.
Shouldn't that just be locked and only the,
Yeah, that's not my issue. If you send them out of wood shop down that hallway, they have to go around the corner, which means they're hidden from any sight line of a teacher at that point, which creates a nook for bad things to happen.
Where does that ramp end?
Right here, right at this location.
Do you know what I mean? Like that's like an under stairwell situation, or it just is, it creates a place where.
we would need that corner mirror then?
Yeah, exactly. I mean,
Yeah.
it just creates an area where kids can hide. I don't,
We could do something.
Yeah, I don't know how often they would go in there, but if you.
I think,
So right now, they don't have any storage, basically, right?
Right.
it's not, but kids are gonna be accessing that hallway, going up and down there as they go back to those. And again, if nobody else sees an issue, I'm just telling you, think under the choir room stairs, think
No,
about where
it's-
things
It's a
happen
good,
that we don't, that's
Yeah.
a nice hiding place right there.
we could do that. I mean, that essentially you'd.
I
you
would
just
like
have to
that
go-
better.
Mhm.
I would like that better, so that the door was on the face of that wall.
That's right. All right. Other questions? Anything else with this plan? All right, we will jump into. Yeah, it's unplugging. So here's the roof plan. What we ended up with here are 3 smaller mechanical units, 1 larger unit based on kind of the zones and how these spaces are being used wasn't going to function. We talked about that at one point. The goal again was to try and push these back, away from the roof edge as much as possible and still maintain clearances required by OSHA. So that's what we have in these locations is the mechanical units 1, 2, and 3. 1, 2, and 3. There's also a roof access hatch down at this location, so that was off that small closet to be able to come up. It's got the surround on it like you need with the swing gate, all that kind of stuff that's required by OSHA right now. So you'd have access to this lower roof area without having to use ladders to get up there. There are roof drains, obviously, and then overflow drains. Overflow drains are used in the case that the primary drains get filled up and you need to get that water off there. They also are a signal that there's a problem on the roof. So if you see the overflow draining to the outside of the building, then you know somebody has to get up there and clean something out. The other things you see on this page, these darker gray areas are areas of tapered insulation. Generally, the roof's pitched, so you see these arrows pointing down to a direction. These roofs are, like this roof, for example, this high roof, is pitching this direction to this edge, and then you have tapered insulation, meaning sloped insulation. It gets patched in at these corners to direct water to the roof drains. These symbolize steps in the roof, so this is higher, so this goes from a low roof up to this roof, this goes from a low roof up to this roof, and then similarly, it steps down into this area here. And then the last kind of key point on this roof plan, this area that you see with the secondary shading, this is that rated roof assembly. So what that is it's a roof cross-section that allows us, it's got the concrete topper on it. It's essentially a rated roof that allows us to maintain these existing windows that are on the second floor of this building without having to fill any of those in. So in a step building condition, you either have to do something where there's a section of rated roof, or you end up having to have a vertical separation between the roof and the windows on that second story space. So this is how we achieve being able to keep those windows. Anything else? The other thing to make note of with that is you aren't allowed any penetrations through that rated roof assembly. It's the first 10 feet off the building in each of these locations. Some of these are a little bit wider than 10 feet just based on how the structure laid out. Some of these are right at 10 feet, so that's what you're seeing here. And that's why the roof drains are outside of that, the access hatch is outside of that, everything is outside of that assembly. Just a couple details, you can see here the rated roof assembly with the concrete in it, and then the areas that don't have the concrete, essentially we just end up putting in a little bit more insulation so that they marry up and are even when they interact with each other. Any questions on the roof elements? All right. Reflected ceiling plans. So what you're seeing with these, this is looking up within the space. So what we have here, in the existing building, the only thing that you're seeing is the rework of having to move the extraction system from the one side of the building to the other side of the building. So there's a little bit of work within welding in order to make that happen. In the new portion of the building, you're seeing the ductwork as it relates to these spaces. So this is the ductwork coming off of the rooftop unit here. These are the duct drops, and then there are lights that are fit into the spaces. They're a little harder to see. They show up more on the electrical plans. That's these guys here. Moving down into this space, this is a shared classroom. The lights are those linear fixtures that we saw in the renderings. Just some diffusers located within that space. You got your corridor with more of the linear lights to match what's going on inside of the classroom space. And then advanced manufacturing is another open ceiling space with, you can see the exposed ductwork, the lights hanging below it in that space as well. Some of these other lines you're seeing these are roof drains, like this location. This would be an overflow roof drain. Outside of that space, moving down, we do have corridors and bathrooms are very similar, open ceiling inside of the small closet with the access hatch. Wood shop storage, we're just going back in and comes, these are all 2x4 ceilings, and then, you know, obviously.
Is that what the rectangles represent?
Yeah, these
The
are,
square-
yep,
Feel it now.
yep. One of the last things that we're working on are alternates. There are a handful of alternates that we're working on with mechanicals and such. Those will kind of build out some of these accessory spaces like cafeteria at both buildings. So we're working on that right now, but primary goal is to get the buildings out, which that's why we have those.
The extraction system in the current welding lab,
Mhm.
did you, that's not disrupting any of the booths that exist, is it? Okay. all
No,
right,
the
okay,
booths,
all
the
right.
booths stay in their
Just-
spot.
okay,
All
all
we're
right.
reworking is some of the.
Is it, okay, that goes up
Mhm.
along the top, okay.
Yep, and one of the other alternate we were talking about is looking at the dust collection system that's in woodshop. We're looking at that as well.
Okay.
So hopefully, you know, if pricing permits, you know, we'd be able to get all this stuff squared away and get all your extraction in these areas done and some of these ceilings and
Okay.
such, so. All right, ceilings. Exterior elevations. Nothing's really changed here since the last time we've talked about it. I guess there's one small thing. We did shift over this door a smidge in order to get that closet in a location. So this door shifted over a little bit, but other than that, the patterning, masonry, all of that is the same that it's been, you know, since a couple months ago. You're seeing here off in the distance, this is the relocated extraction system with the duct going into the building. Primary building is brick down below. We've got this split face masonry up above with, you know, some smooth block to kind of get some of the detailing that's elsewhere on the building. We've got these little medallions that are, you know, spaced around the building to kind of pick up some of those stone features. You're seeing lighting on these elevations as well, so there'll be lights at some of these locations and some cameras and things like that, card readers and such, that show up on the outside of the building as well. Getting control joints, that's something that's important. That's essentially your masonry separations. So that as the building adjusts, it kind of moves a little bit, because masonry does move a little bit. This gives you spots where that can happen. There's that extraction system and such. The windows, those are the same windows we've been talking about. Essentially all these, they're aluminum storefront type windows, so they're the heavier windows with some applied mullions in these locations. These do all have standard glazing at these locations, except for the doors, where we do have the film on the doors. And here you can see that roof hatch with a full cage assembly. This is required by OSHA now, so that is required to be put in. That's essentially it.
Exciting.
That's really exciting.
Building sections. These I'll quickly run through. These are helpful tools for people to understand kind of the general geometries of the building. So you can see, like, for example, in advanced manufacturing, you can see how the roof interacts with some of the walls and the corridor, the existing building. These are oftentimes meant to show generally what's going on, and then it points you in the direction of these wall sections, where you go to this wall section, it gives you a much more detailed idea of what's happening at these locations. So again, you see the interaction between the high roof, low roof, what happens at this spot. It allows you to kind of see how that manifests in the actual building section. Again, just kind of corridor and relationships of doors and the big rated roof assembly, and as it's coming down to that valley, how all that stuff works in that location. Your ductwork drops, your structure in the ceiling, corridor with your ramp in one section of the building and the low slope in the other section of the building to get you back up to that main corridor elevation that's throughout the rest of the building. It's just one more section. This is through shared classroom and then out into the outside of the building. So this is that kind of vestibule space outside. These are general wall assemblies, so it just shows you the brick and the airspace and the insulation and the weather protection on the block, and then the masonry back behind it. This is just really to tell the contractor as they're building it, how all these pieces go together. So you see the sections on the other location. This shows how all these parts come together. This also does give you your insulation values. We have code requirements for insulation values that we have to meet. So this gives you an idea how all that's being achieved.
When you put in like alternate assembly versus the base bid versus, I don't know what's on the bottom, is that like, is that for the contractors who are bidding on it?
So
if they prefer a different method?
So in some of these, we do have a secondary assembly that is a proprietary system that we can look at.
Okay.
And that's one, sometimes it's more expensive, sometimes it's cheaper. And
By
so-
a specific company that? Okay.
Yeah, Dow specifically gives
Okay.
a certain type of insulation that, we go through, we get our base bid, we're on the numbers, then we can look at that alternate and see if that's something that makes sense. So
Okay.
again, sometimes it's value savings, sometimes it isn't. This also gives other manufacturers that may offer that type of system
Okay.
the opportunity to do something like that.
What's the advantage of one over the other?
No big advantage. The one that I'm talking about, the proprietary system, they use essentially board insulation everybody's used to seeing, and they have it's a vapor retarding tape that goes over all the seams, and so you basically put the insulation in, you put this tape everywhere. That insulation and that tape acts as your vapor barrier within the wall, as opposed to putting on the spray assembly and then going over the top of it with the insulation. So conceivably, it would be a more efficient way of doing it. You have one person, one trade that's out there doing all that work instead of having somebody spray on that material and then come back and doing everything. But sometimes it doesn't work out that it's a cost savings. I've seen it be a substantial cost savings, and I've seen it be a substantial add, so it just really depends on the project, so.
You know, when you will bid both options,
Yeah.
it's a small scale, so we might not yield much, it's more labor
Yeah.
thing than anything.
And that's sometimes the more traditional system with the spray applied and the insulation, you just get better pool of bidders that are able to do it, because there's more people that do that system. So just, that's why we like to leave options for how that goes. Wall sections, we don't need to go through all of these. But again, these are another layer of detail, so it's starting to show how the foundations interact, how the walls between the existing and the new interact. Existing is typically grayed out, new is not. So you see infilling windows, you see going through adding a new masonry wall, the interaction between the concrete footers and the existing footers. You see your floor slabs cutting through those spaces. But these are a second level of detail. There's a third level of detail where you jump into the actual interaction point. So example, this one will take you to a 510. And you look at this detail where it breaks down even more, greater detail of how the masonry comes up, intersects with the rated wall assembly. You got your blocking and your roof insulation, your cover board, your little bellow type control system between the existing wall and the new roof assembly, taking that membrane up on the wall, putting a termination bar with some sealant, and then essentially you're flashing over the top of it, type of counter flashing. So it basically closes off that assembly, but it is resolving these details at these locations and telling the people that are building it how they build those specific things. So window heads, window sills, roof coping assemblies, all those sorts of things. Just quickly flip through these, see if there's anything real exciting to talk about. Again, more of the coping conditions, window head assemblies. Same. And again, more wall to roof interactions, foundations, copings. And again, just some enlarged details. One thing to note, I'll just bring that up. We won't have to talk about both buildings. So there are changes in the energy code, so some of these details are more complicated than you'll have seen in old projects. Really, the idea is to maintain as much continuous insulation around structural components as possible. So you have your wall assembly that's out here, there's insulation inside of that, you have your roof assembly here. In the old days, you'd run your insulation up, you'd run your insulation over, and that'd be it. Nowadays, you pull the insulation up over the top of the wall and back down to the cavity. So it's about creating this kind of continuity of insulation, so you minimize kind of your weak points in the system where there's kind of a thermal gap, thermal bridging. There's still bits of that. It's impossible to totally alleviate that condition. You'll have masonry wall ties, you'll have some blocking that's required in there. There's those areas where you'll have some thermal separation that will occur, but the idea is to minimize that as much as possible and create as consistent of a system as feasible. This detail, this is typical foundation detail, will be the same for both buildings, but essentially you have your block wall, your brick out front, you do some protection on the outside of the wall, you've got your insulation in the cavity, you'll fill the core of that space, that air space in between the brick and the block, up to about floor level, or that first area of flashing that goes through the wall with mortar. That's essentially trying to make this as water impermeable as possible. Then you have flashing, so any water that does make its way through the brick gets into this cavity, essentially works its way down and out through this flashing. There's essentially vents, sweeps along this edge that allows that to happen. And then last but not least, there's cavity drainage material. So as they're assembling this brick wall, mortar will tend to fall into the space no matter how careful the mason is. It's a small space to be kind of cleaning the back of that block. This mortar mesh material, it's a meshy material that's kind of got a jig-jag top to it, so that if any of that mortar kind of falls down in there, it prevents it from creating a dam and stopping up the water, because you want the water to get out down here, you don't want it to be trapped on top of that mesh material. So that's really what you're seeing there. And likewise, at the top of the wall, with everything in a building, there's pressures that you're trying to alleviate. So in that core space, in order for this wall to breathe in the way that you want it to, you have vents on the top and vents on the bottom, so it creates an equilibrium within that airspace and allows the wall system to work effectively. Stair sections, really not much there. They're essentially steel frames stairs. The outdoor stair is going to be similar to what you have over by welding currently. The interior stair is a concrete-filled metal pan system, like you would have in every other building that you have on campus, probably, except for the terrazzo stairs. So it's essentially a metal frame system, and they go through and they fill in the treads and the landing with concrete, and then you can go over that with a flooring system and rubber treads and risers. So that's that. This will be the same for both buildings. Really what this is just showing is all your ADA clearances at doors and fixtures and all of those sorts of things. So you'll see a typical bathroom configuration, how it relates to the overlap of the toilets and the stalls, and the clearances at sinks and reach clearances, writing surfaces, tack boards, that sort of thing. These are just standard, so you have stuff in here that isn't pertinent, but there's other information for all the various accessories where they need to be mounted on a wall so that they meet the accessibility guidelines. And again, that's the same for both projects. Bathrooms, we do have enlarged plans and elevations, so this just gives the contractor an idea of where the grab bars go. It shows those clearances again, it shows your door clearances, your sinks. Make sure you get your soap dispensers and all those sorts of things in these spaces, mirrors and paper towels and all those sorts of things.
Did we decide not to go with the urinal in the male bathroom?
We do not have a urinal in there. There was not enough room. We could add one on the opposing wall. It's just getting real tight to add one in that space. These are typical classrooms, so you'll see the enlarged floor plan with equipment called out, and then the elevations. So really what this is intended to do is, again, as somebody is laying out the space, coordinating the locations of outlets, coordinating the locations of the equipment, they can see a representation of, from floor plan to finished product, what that's supposed to look like. So this elevation, for example, these shouldn't be showing up. I don't know what those are. So the way these, just to explain what that is, sometimes the way these models are built nowadays, we have essentially the architectural model, which is all the building components, and then there are all the trades, so mechanical, electrical, plumbing, drop-in, structural drop-in. These could be a structural component that's shown at the wrong location. They're shown right in plan, for example, but they might not be shown right elevationally. That needs to be turned off. I don't know what those are. So, but the rest of this, you're seeing the window, obviously, the control joints, notes for the various counters and backsplashes, and you're seeing the furniture in there and the pieces of equipment in the space and the cabinetry and things of that nature. The structural system across the top, the mechanical working its way through. All those pieces, parts are dropped into these sections.
Can you tell me, Ryan, what do you have, and that's one of the things I needed to have come out of this is furniture-wise, can you tell me, so how many chairs are we do you have placed in the advanced manufacturing room? You know what I mean, like, give me an
We
idea.
we do have all that pulled together, I won't have that number right now.
Oh, okay, all right, so
Yeah.
you'll get that too?
Yeah, I can
So
get all
as
that
I'm
stuff.
starting to, okay.
Yep.
And then the number of tables too, because I have a couple of options that I'm looking at for the classroom space,
Mhm.
but I'm not sure how they'll fit in the space, so I wanna look at, you know, and we can talk about that, but,
Yep.
okay, I just wanted to make sure,
Yep,
okay.
And again, some, you know, enlarged, this is the classroom space specifically, you can see, this does show all the tables and chairs, and you can count them, but we can also go through, and this is a basis, so if we wanted to make some adjustments, or if you have a slightly different table shape that you wanna look at, we can look at those sorts of things and make those tweaks, obviously. The construction trades, pretty basic open box, pretty basic walls. Not a lot in there. This is the other two walls in that space. But again, it's just to show the relationships of all these items. You're seeing accessory items and outlets and things like that along the walls as well. So that's what you're gonna see in that space. Yeah, and these are just general, typical casework sections. So you're seeing typical countertop, what goes into all that, you know, the need to get your grommets and your bracing and your cable trays and such. Typical section through a countertop with drawers and doors, just gives you all the details. So again, these are those tall units that you see inside the classroom with the little built-down soffit above that, take it up to the ceiling, but it gives you all the, you know, the items that go into each of these pieces. And generally, these are all plastic laminate tops, plastic laminate, backsplash, again, that's, you know, this type of material, but a commercial grade plastic laminate material, all the edge banding, so all these faces on counters, for example, it's a 3 mm thick material, it's a rubberized material with a pattern to it, and depending on the pattern we all decide on for the flat surfaces, you can sometimes get the facing to match what's happening with everything else. They've gotten better and better about that over the years. Back in the day, you could get gray or black, basically, but they've gotten a lot better at having facing materials that look similar to everything else, so. That's like back in the day, you'd end up with a lot of black countertops or gray countertops so that the banding matched what was happening with the countertop itself. So, that's that. Just typical window elevations, some details, doors. So this is again, just as the contractor's looking at this, trying to give them the information they need to understand how that window sits within the wall. And so like each of these little call-outs will take you to, you know, a specific detail that tells you how this assembly works. And it's essentially, again, that idea of the masonry wall, on the outside pieces, the window sits in there, a type of some support system. In this case, we've got a steel support with some blocking that allows the window to sit in there to minimize the amount of thermal bridging. Back in the day, you just have block to block, and you just have this really cold spot at your windows. That's all been worked through over the years to try and minimize that as much as possible, so you don't see those big drops in temperature in those locations. It's just door schedule. This takes all the doors, and this is gonna be the same for both buildings, the concept is, but it gives you all the doors within the building, gives general locations for the doors, gives sizing, panel types. So again, each of these breaks down to a schedule. It's located over in this area, so there's door abbreviations and glazing. Glazing being the glass types. The door abbreviations, so as you get into panels, for example, this door into advanced manufacturing has an NL, which is a narrow light, which looks like this. And so it gives the person the idea of what all these pieces are. F is a flush door, NLs are narrow lights. These are storefront doors, so the SWS is a wide style storefront door, so that's a heavy duty aluminum storefront door. So those are exterior doors. These will give you material. So again, I just told you this was a wide style door. ALGL means aluminum and glass. So you know that this is a wide style aluminum glass door that's 7 foot tall, 3 foot wide, and these are the details. So it takes you to all those parts.
In case I would ever need to know.
In case you ever need to know
Thank you,
that,
I
yes,
appreciate
yes.
that.
Somebody might care.
Somebody will along the way, it's just probably not me.
This is typical partition types, so we're not using all of these, but this points to, as you're looking at the floor plans, I'll bring that up real quick. So there's a lot of information on the floor plans that most people won't care about, but there's things like this M 1.8, and you can go to this sheet and you can find the M's 1.8. And that tells you how this wall is assembled, and it's nominal 8-inch CMU masonry wall system. There are also additional abbreviations that can go with it that tell you if there's fire ratings associated with the assemblies and things of that nature. The way our building is being built with the sprinklers in it, there aren't a lot of different types of wall assemblies required, and since we're doing masonry everywhere, it's a pretty simple, straightforward building. Partition details, so as each of these partitions go to somewhere, just general walls, it's just sitting there, it's one thing, but as you get to an intersection between a wall and a ceiling, for example, or a wall and a roof. So here's our rated roof assembly, this is how the wall comes up and interacts with the metal deck, you know, the metal that's going across the roofing. You're gonna need some support so this wall doesn't kind of teeter-totter. You're going to need some infill at the top of those walls to kind of complete the assembly as it interacts with the top. You want to create a little bit of space there, so if there's any deflection in that roof, it's got the ability to move a little bit as well. That's one thing to consider here, and just explaining what that detail means. You hear your roof moving. At your walls, at your support points, it doesn't move, but as you have a beam going across the space, there are walls in between there. This roof does move a little bit. So it's supported on the two edges. The roof in the middle will have a little bit of a tendency to move up and down depending on if you have a bunch of snow, if you're putting some rooftop mechanical equipment up there as they're doing construction, any of those sorts of things that you're doing up on top of the roof, there will be some deflection in that roof. So any wall underneath that section of the roof, you don't want it to be rigidly fixed to that roof assembly, because it will have the tendency to crack or to cause the roof to have some issues. So that's why you have a little bit of deflection potential, at some of those locations. But this just goes through and talks about all those details. Intersections, perpendicular intersections between two different walls that are coming together, and how you treat those edges. These are control joints, and talks about your rubber stopping that happens within the wall, and kind of your sealants and things of that nature that happen there as well. So that's what these are. And then last, there's just signage, general building signage. It shows locations where they go by doors, the general basic information that goes along with these. These are our basic signs, so as we get into the submittal process, we'll fine tune the text that you want to have on those. So as you want to, give name to that space, that's what these are. If you decide to add, a more decorative sign, maybe the CTE program builds a sign that happens over by construction trades and goes on that nice big wall we have there, that's different. These are code-related signs that you need to have, so that as the fire department, police department's coming through the building looking for an issue, they can find those spaces. These also are required for people that are visiting the building to be able to find their spaces that they're going to. It has text and braille that are required by code, so that anybody utilizing that space has the ability to find their way throughout the building. So from an architectural standpoint, any questions on any of the stuff I've covered? I can jump out to civil quickly. A lot of this we won't go over. So, this plan, and the other plans from a civil standpoint, they basically show location of the building and shows all our interaction points with various utilities. Probably this wasn't the best plan to pull up. That was more of a geometric plan, this one's better. So we have the various utilities, there's existing gas on the site that we have to relocate a little bit. Just adding a little bit of a clean out and a storm connection for some of the roof that's going in through here. It talks about this little T for the gas. It talks about the extension of the electrical into the main space. So it talks about all those various aspects. It also shows locations where these interactions will happen. This is being reviewed by county engineering about all the connection points and all those sorts of things that go along with site utilities. So this ultimately gets reviewed and we'll get a permit for that as well, but there might be minor manipulations of this.
Is that why it says proposed gas line instead of?
No, that's just to make clear the difference between these and the existing in this condition. That's the idea. So that's really what you're seeing here. The one thing that we needed to do, she is working through, is this driveway did not get fully vetted out in her site plans. She's making some adjustments here with the relocated cooler, adding a little bit of width onto this driveway, and then the connection points over in that location, and then the patio. She's finishing up the patio space as well. So there's
Who's she?
our civil engineer.
Oh.
So then we have lots of different people working
I
on
know,
this.
it's
Yeah,
like she, Michelle
Yeah.
Gifford was,
yeah.
our nutrition person was.
Oh, no,
We're
that's
organizing
not
the
her.
cooler
It's
back
not
there.
her. No, we've got a couple of civil engineers that are working on this. And then grading plans. Now on to this one, she's just showing extents there, she's just showing points. So this survey wasn't quite what we're typically used to and how it was assembled, but she's showing a lot of point information to give an idea of how all this building interacts. So it's locations around the outside of the building, gives you grade, and it gives you finished, FF is finished floor. So it gives you an idea of how all of these are interacting. Essentially, the building will be built, there's about, from this area back here to out here, there's about 2 feet of difference. That's where we had the foot drop in the floor, inside of the space. And then there's another 8 to 12 inches as you get out to that sidewalk. So it's showing how all that kind of comes together, but the building will be built, and essentially this will be feathered out is what's gonna end up happening. They'll take, an elevation here and just work it to those edges to get it to be as, seamless as possible. There are some information like this. So with all of these projects, you have stormwater pollution prevention. Here's a plan for it. But essentially that talks about as you have drains around the outside of the building, you have to, and as you're doing active work within the space, you have to protect drains. You have to put up silt fence and protection around catch basins and such so that you don't have a bunch of dirt running into your storm drainage system. So this talks about the placement of those, and then the requirements for those, and then there are details that show, again, here's a catch basin, this is what you put around it to prevent stuff from getting inside it. If you have a slope, then you put in these type of filter socks, which are essentially material, like a netting type material with filtration type, it's generally straw or something of that nature within these bags that get staked and prevent, again, silt from flowing through those spaces. So it talks about all those various aspects of protection. General notes, general details, and it's basically site. Trying to think anything else. Is there anything else specific you wanted to cover on the building?
That gas line you're moving,
Mhm.
Rich, does that have anything to do, is there 2 different gas lines out there?
There are a couple.
There's a
Yeah.
couple.
Yeah.
Okay, so I don't have to worry about that with that proposed generator yet, right?
If we pour a new pad in May,
Say that again?
I said if we have to pour a new pad in May, but that gas line may be moved before we put a pad in for a generator.
Yeah, we've got a little bit of an anomaly in that and this is something that as they start doing their site work, and early site, we'll have to verify, but the gas that's shown on the survey doesn't necessarily gel with the record documents. And the surveyor confirmed, and the guy out there that was doing the finder service confirmed that what he was showing on the survey matches up with his understanding what's there. But essentially you have, again, this is welding here, this is student dining, this is food service back here. This is that big main. There's that big gas main over here. And they have a little bit of information for that big main here. And then when they were kind of working through, there's gas that goes under the library addition. On the library drawings, it shows a 4-inch up to here and it goes down to a 2. This is like an 8. And their understanding was this connects. We don't know if that's necessarily true. They have some points that as they're going through finding the gas line, they were able to spot it to here at this location, this line. They don't have size for that. They have this size. This is a little bit of interpolation. There is also a gas meter at this location, and there's a gas meter here. So we're speculating this might actually go to this location underneath the cooler. This is a smaller line. This is 1.5 inch or 2 inch here, and this is 1 inch or 2.5, or 1.5 or 2 inch going into the welding. So there is the potential. This is a smaller line that goes to these spots. We don't for certain know exactly what those do until they're able to do a little bit of field investigation to verify some of those sorts of things. So
Ryan,
potentially that will change. a
Is
little
there
bit.
any potential for an issue with us having to reroute the gas line that does go underneath the 94 addition?
From everything we've been told, no. They've told us that they're not gonna prevent us from doing the addition. To say 100% that they won't give us fits for that, I can't say that. But from everything we've been told, similarly with electrically, they said they would like us to do more substantial improvements to service, but they're not going to make us do anything more substantial. Everything you have there is essentially grandfathered in. Codes change throughout time, requirements for all of these services have changed throughout time. It's always the utility's desire to bring everything up to current standards where possible. And sometimes that's just not feasible. You have this giant building on a large campus, and routing of some of these utilities over time is just not the way they would prefer it to be done now. So that's that in a nutshell. In this area out here, there's a whole bunch of stuff. So, I mean, there's potential we might run into some small, drain lines or something in this location, but there's nothing on any of the existing drawings that would lead us to believe there's anything in here much more than this gas line. So, that's that. All right, any other questions on CTE? I can jump across to Riverview.
So there's no, with these drawings, the way that things are put together, we're still kind of, everything's good, no foreseen bumps or anything like that?
From our side, no. And
Okay.
we've submitted to the building department for their review. So essentially, there's a building department review. That's where they look at all the pieces, parts of the building, how it's assembled, all those sorts of things, life safety code, mechanical, electrical, plumbing, all those sorts of things. There's a zoning code, which is local ordinances that say, your building heights, your location off property lines, fencing requirements, all those sorts of things. That's been submitted for review. There's fire department, police department review. That's where they go through and they have their own set of standards. Fire department, police department can ask for things outside of building code requirements. So for example, if they want another key box located in the building, or they don't like a door swing, or I've had it where they've actually asked us to remove like call stations, which is, call stations were required by code, but they didn't want them. So they can overrule building code standards. So that's been submitted to both of them for review. We had those preliminary meetings with them, and I don't foresee any issues with them. It seemed like they were very I think they understood the projects, and I don't anticipate anything significant from them.
They did, I remember them asking about sprinkling into the wall.
And we have that
Okay, that's it.
included, yep.
Okay.
Yep.
And then,
A page you could just slap
I
on.
just lost it.
We could put something in.
And then last but not least, there's engineering, and that's all your primary utilities going to the building, storm drainage, you know, any of those sorts of things. They do that review.
And then the alternates get sent out with this as well.
So the alternates we're working through,
Okay.
that will be on the back tail end. of
Do
it.
you know if we put,
But you know, that would
because I
be
noticed
just
this as we did the 75th, the flooring for the commons, do we put that as an alternate?
That
Or is that in the
is, I don't recall. Oops. Oh, pull it out. So we do have flooring in there.
Okay.
Yep, so.
So the compass
these
rose
get-
will be
yeah, this,
covered.
basically where we're cutting in these walls and making adjustments, we have flooring in all this section.
So the whole section or just the,
This whole bed,
okay, good,
so that all gets flooring.
over the compass rose.
Yep, yep. All right.
It does point north.
It does.
Making fun of my
Let's
directions.
let's not get into that again.
I don't live in your angular world.
Just point me in the direction of Lake Erie, there's north.
So we have Riverview next. These are just overall plans. This is more for the building department than anybody. Just show relationship between the addition and the rest of the building. This is for them to be able to look at it and say, I've got a corridor coming down here. How do I resolve my corridor? You know, is there a stair? How do people get out of the building? That sort of thing. It's really to give them those broad bits of information. So these are the enlarged floor plans, very similar to everything we've talked about previously. This is the interaction point with the existing building, the existing stair location. This is our new entry off the west side of the building, true west. So as you come in here, there's a canopy at this location, there's a vestibule off of that, secure doors, glassy entrance here, window off this side. This is secure window with pass-through in it, the little voice communication between those two spaces. Door into the secretary space, reception, however you want to deem that. There's windows into these two rooms. There'll be a counter. This is that little wardrobe unit that we had talked about. So there's space for coats and personal items for the supervisor and secretary in that space. And then this is the office back behind that.
I have a weird question as I'm looking at that. So if something were to ever happen and
Mhm.
someone comes in those main doors, does the secretary and the supervisor, they're trapped there then, aren't they?
They don't have a second door out, no.
Do we find that to be a concern from a safety point of view? I don't know. It just dawned on me now that somebody coming in, like, there's no way out for those people.
So this
I
depends
don't
on how
know.
it depends on how you view it. So from a code standpoint, there's no requirement to have a secondary
Right.
door out of it.
Okay.
Think about, there are 1 million rooms in this building, like each classroom has one door in, you know, so.
Yeah, but nobody's coming in from the outside directly into facing.
That is the difference. And so
Yeah,
you could
okay.
potentially add a door out of that space. The question is how would you want to do that? You could add a door to the outside. You can add a door to a classroom, which would be kind of weird. Probably door to the outside would be the thing to do, but then you have an access point where somebody
Could come in.
could come in that door.
Okay.
This one,
Do it
is
as one of those windows?
I don't know. It just, like I said, as I'm looking at it, I don't know. That is,
If there was an issue, couldn't the secretary just go into the office and shut the door?
they could,
And I
and
think that would be the cheapest option.
Yeah, I mean, you could do something like that, and then it might be something that you do have, like a window break or something, you know, within that. Of course, these windows, you can't really break them. They do have the outswing on these W1 windows, so they are egress windows.
So
So I guess maybe that's your answer, is you could
That's
get back to the
egress window,
supervisor
okay.
and egress out of that window.
Okay, that's all I wanted to know, is that there was a way out of there, so they're not, I mean, when we think about what happened at Riverview, the principal trapped or a supervisor trapped in that room, not being able to
Mhm.
assist with what's going on potentially in the rest of the building.
Yeah, and
Could be a problem.
And there's no perfect solution. I mean,
Right,
the perfect
yeah.
solution, every room would have 2 doors, and that's kind of impossible to do. But I get what you're saying, since this is right off the main vestibule. But we do have these W1 windows, which are.
And those are egress
Those
windows?
are all the
Okay.
egress windows. So, you have that.
Okay.
So there is that. Moving back into the space, there is, you know, there are a set of doors here to section off this portion of the building. As you get into the corridor, there's the stair up, there's a little custodial closet that's tucked underneath the stairs, so you have all that in this section of the building. There's the 4 primary classrooms here. Again, they're flexible, so you can use them ultimately how they, you know, need to be used in the future. But each classroom has a wall of built-in cubbies. They've got the bench type with the boot space underneath. There's a section of flat casework with a countertop and some overhead units, under units, sink space in each classroom. And then there's the teacher area of the room, which has wardrobe, and it's got space for some of their personal items, and it's got area for, there's a little section of counter over there in that space, very similar to everything that's happening in the
Okay.
existing rooms.
Perfect.
Yeah, so we just modeled it off of
Okay.
what those existing rooms are. Also, each of these primary classrooms has access to a restroom, so these have the individual restrooms. This one has the shared restroom with the access to a space for changing table, and it has enough room, you could fit a Hoyer lift in there if you needed to. And then the last bit on kind of this floor plan, there's 2 things. There is the storage space that we carved in between these 2 classrooms. So as you have access to playground, you could do some stored space or some stored items, you know, off of this door if you wanted to bring those in here. But it's also a larger storage space for the primary classrooms as well, so that they can put items that are not used every day necessarily inside of those spaces. And then last but not least, there is the rework of that existing stair and kind of this area down here, adding a couple doors so that you section off, you know, the new building from the existing building. You have your egress that gets you out to the courtyard space, but in order to get that egress, there's an existing wall here that needs to be cut. We need to rework the stairs to get a little bit more height underneath this stair landing in order to do that and get out into that space.
Is there any storage under that staircase?
There is not. No. Generally, you try to avoid that. You do end up having to rate the underside of that stair if you need to. In this location, there just wasn't, by the time you have that riser going up, there's just not that much room. Like if these doors could be shifted over and we were able to kind of section this off, then you have enough space, it might make sense. It's just, this is the lower section of that space, there's just not that much room there. Second floor, here's that stair coming up, again, sectioned off. We adjusted some of these lockers in order to make that fit. We oriented the doors in such a way that you could get those positioned within that space and maintain lockers in between. Moving into the main space, we have the mechanic room with all the mechanical equipment, lining up louvers, mechanical louvers with the equipment, so it kind of aligns with our window spacing along the section of the building. Down at this location, we do have a restroom that's available to these classrooms. There's enough space we could get a changing table in there if needed. If not, it's just a slightly larger restroom. There's 2 small group rooms. So again, you can have kind of break-off space for specialists or things of that nature in those areas. And then there are the classrooms. Again, they have a wall of cubbies in each of those rooms. So depending on whoever is in that space, they'd be able to utilize those classrooms effectively. There's a similar sort of casework with sinks built in, flat, some tall storage, and then those same teacher units. And then on the second floor, we do have these doors between the two classrooms at each of these locations. So you can open those up and have access between the two spaces for co-teaching and things of that nature. So those are floor plans. Roof plan, this isn't typically how I would do it, but we're matching the existing building roof drainage system. Essentially, they created a high point down the hallway and they pitched it to the outside walls. We generally do the opposite, but we're just matching the existing building, how all that's done so that there's consistency throughout the building. This isn't wrong, it's just a different way of doing it. So that's what you're seeing here, the pitches, the insulation and such. Reflected ceiling plans take a big cue off the existing building. So again, just general classrooms, just general 2x4 drop-in ceilings. We do end up with these little curved elements in the corridors. They do replicate what's happening at some of those existing class sections where they have these little bump outs of this drywall soffit. So you're seeing that in there. Other than that, there's nothing really too crazy with the ceiling plans. You're seeing some of the diffusers and speakers and occupancy sensors and all those sorts of things that are necessary in the spaces. I want to say too, we're going through the process now. We're going through permitting, as I mentioned. There will be questions that happen during bidding. Ultimately, what will happen is all that stuff will be put together in a consolidated set. So, if there are any revisions during permitting, if there are any revisions during bidding, all that will be put together in a construction set, essentially, a consolidated construction set. So we'll clean up some of the details that need to be cleaned up a little bit as well, and ultimately a final set of that will be issued when we start construction. Just more typical details there. Overall elevations, these are really meant to mimic the existing building. You can see that. Essentially, we're just marching down the side of the building with the same sort of materials, same sort of spacing, detailing, all that stuff. Just really replicates what's happening in the rest of the building. Here you see that entry piece. It's a little hard to see in an elevation standpoint, but essentially there'd be a metal coping, column at this location. There's a pier at that corner to accept that little canopy element out there. Windows, again, kind of walking around the outside of that building. There's that door that gets you into that storage space, the louvers to get you into that mechanical room, and then this is that condenser that's outside on the ground. That's that. Overall building sections, again, real simple. You can see the stair, you can see the relationship of the hallway. These are the ceilings with the ductwork running down, in that plenum space. This is the relationship between the taller portion of the building and that entrance section with the office in it. Just show a relationship of the structure coming across, ceilings, the windows, the pitch of the roof, how all the structure works with that. And then, obviously, it has all the call-outs to the wall sections. More building sections. This shows that canopy again, canopy out here with the column coming down, masonry piers so that you kind of protect the base of that column as it sits out there. Wall sections get more into the details again and give you call outs. So it's just general assembly here. It talks about how all this stuff comes together, interaction between existing and new, interaction between high and low, and then it gives you call outs to each of these locations to take you to the specific details of a coping or a roof wall assembly as we talked about coping assemblies, as we talked about on the CT. It's very similar in nature to how all that comes together. This one, we have the wall assemblies called out on here. There are really two for the outside of the building. It's a facing concrete masonry unit that's either got just a single 8-inch backup, or in some locations where they have those piers in the plan, they ended up doing a 4-inch behind that as well to make the wall essentially a thicker wall system, and that's what we're showing with those two wall systems. More of the same. This is more detail on kind of how that canopy works with the elements of the canopy and the base below it, how that extends over that space, creates that area for you to get your lighting in and all those sorts of things. Your ceiling element, or your roof element, I mean, and you know how that drains to that whole valley, roof drains and such. Wall section details, similar to the last one, talks about how all these pieces come together. It shows that continuous insulation element that we talked about, brick in the block. Well, in this case, it's just block and block. But it talks about all those parts, talks about the foundation, talks about the drainage and everything that's in the wall system, similar to the last building. Again, very similar details. Plan details, so this one does have those piers that are built out. This is what I was talking about with one type of wall assembly and a secondary wall assembly. This just shows how that looks in plan. So as somebody's marching down the side of the building, building this thing, they can see how all of these things start to interact with each other and work their way across. It also talks about, since we have the existing building, how this comes in and kind of marries up with that existing masonry and how all those sorts of things work. Probably don't need this one. That's a pretty basic detail. Stair plans and sections. So this is the existing stair as an example here. It talks about how the old stair needed to be pulled out. We put in this new stair to get us the clearance underneath the stair that we need. We need 6'8", 6'8" clear underneath here in a stair egress path. So this is showing that. This is showing taking that old wall, reworking that wall, straightening that out, putting the new cap on top of that wall. It's got that curve going on it right now, but the way our new stair comes up, it won't interact with that quite as well. It won't interact with it very well at all. So that's why we needed to adjust that. And just shows the plans and some dimensions and talks about how all that goes together. Sections in both directions, shows the handrails, all those sorts of things. This is the new stair that's in the new addition, and same stuff, just different stair. So it shows the interaction with kind of the corridor coming across. This is the path actually that gets you out into the main lobby space. There's the ceiling down the corridor. We need to kind of step that with some drywall to kind of create a bit of a bulkhead there for it to die into, to transfer some of the mechanicals. That's happening over this section here. And then there's the side to it. So as you have the stair that's going up, you're going to have your ceiling that's lower in here. And this shows how you would have a soffit that drops down essentially to accept the ceiling as it comes in and provides that, you can see the soffit underneath the stair there. Just that interaction to accept that ceiling down below and kind of finish that off. Talking about accessory placements, stair details. These are just basic dimensions. So this just talks about if you have a steel stringer, how it interacts with the masonry, how your railings all come together, general heights for all of these sorts of things, and then the infill materials within the railings. So in this case, it's all pickets, which are these guys. Talks about what those are and how those are put together. And again, this is that steel pan stair assembly with concrete infill at all these locations. Arch plans, these are bathrooms, nothing crazy here. Just general layouts with all your clearances required. The walls are gonna be blocked with epoxy paint on them, so they're gonna be super durable. So that's what you're seeing in these locations. Shows relationships of grab bars and all those sorts of things as well. Some of the classrooms, so again, you can start seeing the furniture layouts. These furniture layouts are mimicking what's happening in the existing building. The types of furniture, the placement of the furniture, the rugs, and all those sorts of things are matching what's in the existing building. It shows a relationship between the teacher desk and that kind of workstation. Shows the cubbies, and then it elevates those, so you can see the cubbies with the storage and all those sorts of things. There's a ton of storage in these rooms. They're gonna be very nice. It shows displays and all those sorts of things as well. These small group rooms, more of the same idea. It's just showing the relationship of, these are the offices, these small group rooms, just showing the relationship of displays and countertops and all those sorts of things in these rooms as well.
Could there be storage in those small group rooms?
So this one does.
The bigger of the two,
bigger-
okay, perfect,
Yeah,
okay,
yeah, that one's got this wall,
okay,
so it's got everything in there.
okay.
It's a very nice room. Casework sections, it's gonna be similar. It just shows the relationship of all the pieces, parts that go into the casework. Again, all plastic laminate. These are the student cubbies, so it's a cubby in section, there's a boot box, that you can put your boots in there, shoes in there. It's got the hooks, it's got essentially a built-in bench space, and then, you know, overhead storage, teacher storage up above.
Do we have to figure out who did the casework, or can we get similar colors so that they, you know what I mean?
You can get similar, yeah.
We know who did, we know who did the
Yeah.
original.
We do, okay.
And they're on the bid list, but even if they don't price out as well and you are, you know, if somebody else comes in with a better price and that's who we decide to go with, the laminates are not proprietary, so you should be able to get laminates.
Okay, as long as it's similar too, I just don't want
Mhm.
it to end up all brown down,
No,
you know
no,
what
no,
I
no.
mean? Yeah.
And any manufacturer of the laminates, they've got, you know, 100 colors each,
Okay.
you know, patterns. So there's a bunch of different
Okay.
options, so we can find something, if not exact, because sometimes the pattern you have might go out of existence. You'll find something
Similar,
complementary.
yeah, that's fine, okay.
Yep. Doors and window information, this one does have the windows we talked about. This is the entry security window, so it's got the speak-through device, it's got the stainless steel frame and counter piece with a little pass-through. So this is a purchased assembly, and it basically just fits in the opening. It's got all the bells and whistles, that makes it a fully, you know, protected space. Granted, anything can be passed through eventually, but this is intended for this purpose. It's a design system.
Is
that's
there-
intended for it.
On the entranceway,
Mhm.
they all have those buzzers with the cameras.
Mhm.
Is this one of the ones that will connect to the front office, the main office as well? Should we look to do that? And I think this is more of a John, but when you ring the, in case there isn't a secretary there, or we don't have anybody, and somebody rings that doorbell, we'd want like a second point of contact to man the door.
We wouldn't let anybody in there if there wasn't somebody
Well-
there, would we?
We could put a master station pretty much anywhere.
Okay.
As long as we use the same ones we're using here, they can plug into the.
Do we
network.
have those at Riverview now, or,
Yeah.
okay. And so that would work with a separate,
Yeah, we could tie into the existing ones that are there.
okay.
So there you go.
There's my- All right.
Partition types, really basic here. It's all basically block wall. So there's not a lot. It shows the interaction with the head details, and floor assemblies, and how all that comes together, but it's a pretty straightforward building. Signage we talked about on the last building. Demolition plans, there's more to this, probably not a lot. It's basically the stair, so we're doing a little bit of rework of some of the ceiling. There's the stair we're pulling out a section of that wall to make all this work. And then on the first floor, we're obviously taking out those doors and then cutting in that new opening. So you can see how this pass-through gets cut in and how all that stuff works. From a site standpoint, let's use the utility plan. So again, building addition, this was her first attempt at playground for that space. Honestly, haven't had a chance to look at this. This does not-
It looks like.
think the wheel of death.
Yeah, this is a play structure,
Okay.
but you're seeing all this storm drainage coming out of that. I think we could pull that closer to the building. I'm not exactly sure why she pushed it out so far.
Yeah, we'll have a lot of discussion on that alone, so.
So there's some adjustment, obviously, that we could do with that, but this shows the relationship of that condenser and how the pathway will get through and the existing, or the new building and the existing building in this location. This also talks about a parking lot, and then some proposed detention at the far end of the property. You have a large detention basin down here. The fall, just elevationally, to get all the water back over there, you'd need to pump some of this water to get it to this location. So that's why we do have some detention at this location, shown at this end of the property.
Ryan, the fall on the property,
Mhm.
you're saying some of that is static or to the north? Because it looks like most of it comes to the street side.
So there would be a lot picked up there. There would be some from a quality and distribution standpoint that would need to go to that location as well.
Okay.
So that's what you're
And
saying.
there's presently a drain basically along the driveway towards the detention pond right now.
Mhm.
I don't know if you were aware of that.
Yeah, and she was picking it up somewhere.
So anyway, I'm just saying.
Yeah, I'll have to talk to her.
Yeah, it would be almost where the new parking is, straight down towards the street.
Gotcha. Yeah,
I'm not so sure anyone knows it's even there.
I'll bet that one.
What kind of room do we have between the proposed parking lot and property line?
So, she has setback shown, so there's at least a 25 foot setback, so it looks like it's probably 30 feet. and
So it's
then
too
50.
narrow to do anything there, huh?
Yeah, I mean, you'd end up essentially with a swale along that edge. You could potentially do something at this location. I think the thought was to push that back there.
I was just wondering how that would interfere with any of the fields, the proposed fields,
There's nothing there right now.
but what we have in the future, we
yeah.
don't know, yeah.
And again, I could ask her if this is viable. We could potentially ship something over there. I'll see if that's possible. There just might not be enough room to get the depth we need, so.
We are calling out a fence in the construction project.
Yep. Yeah, you're seeing that around here. That's that dash and X's, those are events. We do have new gas. There was a lot of conversation about the existing gas. The existing gas service comes in over here, and we are over here. We had talked about going outside and digging, and you'd be going through all kinds of sidewalks and under paving and all kinds of other utilities going into the building, or going through the building is nearly impossible. The other alternative would be to go up through the roof and go across the roof. That is also extremely tricky, and you'd have a large gas line that would be visible in multiple locations. So probably the easiest, most effective way, which it's just a straight run out to the street with the new gas line. So that's what you're seeing there. The interactions are very similar to what we talked about previously. You know, you've got that existing loop, drive loop. Maybe the other plan will be a little more simple to look at. It's another one. Click this in. Yeah, it's still tough to find. There you go. So it's got the drive out here. This is our intersection. There's existing sidewalk, crosswalk. As you come back here, there is a drop-off area along this edge. Access to the playgrounds. This is that connection of, there's an existing asphalt pathway, the connection to that, and then interaction with the existing path that heads this direction. And then this is just showing you your general loop around that space, some of the radiuses and such around that as well. Lights. That's what you're seeing. So that is site in a nutshell. Is there anything else? I guess the rest of it is just primarily structural technology. I think we could cover offline. Is there anything else anybody would like to see? And again, these are all available, so we can, I believe you got a link to everything, but if you haven't gotten the link to the drawings, we can send that across, and then you can have access to it and, see all the drawings. And if you have any questions, or if there's anything you wanted to look at, you can obviously do that yourself, or contact either myself or Nia, and we can run through the drawings and point you in the direction of information that you might need, like furniture.
I know it's gonna be done, but I just wanna make sure that, when we get to that detention pond, that we have the engineer from the county standing there and verifying that he's happy.
Gotcha.
So he's not coming back afterwards because there's water or there isn't water, or he didn't like him the first time. I just want to make sure that we.
Gotcha.
What was his issue the first time?
He doesn't think they were done right. And he doesn't like the fact that there's water in them either. And supposedly there was verification of the depths. He doesn't believe it, so I just want to make sure we do our due diligence, so there's none of this coming back afterwards.
Yeah, appreciate that, Rich, because they might be like 3 or 4 feet too deep on their front one.
Oh,
So anyway, yeah, we'll collaborate this time and get it right.
Any other questions, comments? Really, this was meant to just generally run through the building, but if there's anything specific, probably from a detail standpoint, closing the loop on any concerns, Rich's team might have from a MEP standpoint, if there are any questions on that, I think that'd be an advantage. And then from a technology standpoint with John, we'd be happy to have those conversations as well. Any other questions? Everybody's so quiet this morning.
Thank you.
Yeah, thank you so
Yeah.
much.
That's good.
Thank you, everybody.